Students, here we go for the next problem. In figure, a square OABC is inscribed in a quadrant. So it is inscribed in a quadrant OPBQ. If OA is 20 centimeters, side of the square is given 20 centimeter. Find the area of the shaded region. So it is a quadrant, right? So just quadrant, area of this quadrant minus area of the square we will be getting. So area of to find the area of the square we need side is that. To find the area of the quadrant we need radius. So radius is OP, or else we can connect this, right? Diagonals of square is also a radius now, since it starts the circumference, and we know that is a perpendicular. This is 20 centimeter and this will be also 20. So we can use Pythagoras theorem to find the radius. So by Pythagoras theorem, OB square is equal to OA square plus AB square. So OB square is equal to 20 square plus 20 square. That's a 400 plus 400. Directly I am writing. So OB square is equal to 800. Then OB is equal to square root of 800. So square root of 800 means 8 we can write as a 2, right? And this is a 10. We can write as a 2 into 2 into 2 into 10 into 10, right? So this pair we are taking out, so it will be that 2 into 10 is 20 square root of 2. This is the radius. This will be the radius, right? So we can now find easily the area of the shaded region. Area of shaded region is equal to the area of the quadrant. The full figure shape is quadrant minus the area of the square. Square, we know this side into side. Side is 20 centimeter. So quadrant is a 1 by 4 into pi r square minus side into side. So 1 by 4 into, they said to use pi is equal to 3.14. 3.14 into the radius is given 20 square root of 2. 20 square root of 2 into 20 square root of 2 minus side is equivalent 20. 20 into 20. So square root of 2 into square root of 2 is a 2, and this will cancel for 2 times, right? And this 2 and 20 will cancel for 10 times. So 10 into 3.14 will become 31.4. Here 20, the 0 is 314. So 314 into 2 will be getting as a 628 minus 20 into 20 is 400. So here the difference is 228. So 228 centimeter square is the shaded region. So just a square is, side of the square is given. We have joined the diagonal, and diagonal shows that it is a radius of the quadrant. So using Pythagoras we found the radius and we subtracted the both the shape. Quadrant minus square, we get the shaded region. So here we go for the next problem. In figure, ABC is a quadrant of a circle of radius 14 centimeter. So it is given as a 14 centimeter. And the semicircle is drawn from BC. So for BC as a diameter, the one semicircle is drawn. We can see ABC, this will be the quadrant and this will be the semicircle. So as a diameter is drawn, find the area of the shaded region. You can see that, just add this quadrant and this is the semicircle, right? And this is the triangle. So by adding this triangle and the semicircle, we get a whole figure, right? This area of this triangle plus area of the semicircle, we'll get a whole figure. From this whole figure you can see the quadrant is cut out, neglected. So that is our formula we have to create here. And we know we have a radius for the quadrant, sides of the triangle, since it is a right angle, the given quadrant it is right angle, so triangle is half into b into h. We need the diameter of the semicircle or radius of the semicircle. This we can find by using the Pythagoras theorem. So BC square is equal to AB square plus AC square. BC square is equal to 14 square plus 14 square. So BC square is equal to, we'll just take it as a 14 square outside will become a 1 plus 1. That's a BC square is equal to 14 square into 2. And if we take a square root, it will become a square. We are not taking square because since we can take a square root, so 14 into square root of 2 centimeter. So for quadrant, radius is equal to 14 centimeter, and semicircle radius is equal to 14 square root of 2 by 2 centimeters, since it is a diameter, right? And one more shape is the triangle. So triangle base and height are the same. So base is equal to height is equal to 14, since it's both given as a same. So area of shaded region is equal to, first we are combining the two shapes. Which two shapes? Triangle plus the semicircle. So whole figure combined. So area of semicircle plus area of triangle. With that, what we are cutting? We are cutting this quadrant. So after looking the full figure shape, we are cutting this quadrant. We are cutting this region. So we'll get this region, right? So area of quadrant. So area of semicircle is half into, and 2 radius are there. Let me call it as 1 and 2. So semicircle is 2, or 2 square plus area of the triangle is half into base into height minus quadrant is 1/4 of pi r1 square. So 1 by 2 into pi is 22 by 7 into r2 square is a 14 square root of 2 by 2 into 14 square root of 2 by 2 plus half into base into is a 14 into 14 minus 1 by 4 into 22 by 7 into also 14 into 14, right? Let me try it here. So square root of 2 into square root of 2 is a 2. I can get cancel 1 2, and this 2 can be cancelled for 7 times, and this is also for 7 times, and here the 2 is for 7 times, and here 4 2 table 2 times 11 times, this 400 is got for 7 times, right? So here 22 into 7, no, it is of 2 times, no, right, this 7 and this 7 also we can cancel, right? So 22 into 7 is a 154 plus 7 into 14 is a 98 minus 11 into, or this 7 and this 7 also can be cancelled, and 11 into 14 is 154. So 154 minus 154 is a 0, so we'll get as a 98 centimeter square. So mostly it will be get cancelled, so no problem. Clear? So here just we have to view the figure properly. Just this combinations of a quadrant, combinations of a triangle and the semicircle, and this with that this quadrant is neglected. So here calculate the area of design region in the figure common between the two quadrants of the circle of radius 8 centimeter each. So it is given 8 centimeter, and this shape they said it as a quadrant. Can you see that? This is the quadrant, and here also just consider this as the radius, and this will be in the shape of quadrant. So we have to find this area. So we can find here in the two ways. The one is, so from the entire square just we are adding this 2 quadrant, and it will 2 times add, and we can subtract the square 2 quadrant plus subtracting with the square. Or else you can just take a 1 quadrant and just I'm going to connect this as a triangle. So this quadrant, if you choose this quadrant A, B, E, just subtract this triangle, lower triangle, we will get this region. The same from this quadrant, just subtract this triangle, we will get this region. So I will draw one here. This quadrant like this, right? And this design is that, and I connected here as a triangle. So from this whole quadrant I am going to remove this triangle, so I will get this region. Same I am going to apply for the top, and I will get this region. So just both I am going to add. And here don't want to worry, the side and radius both are the 8 centimeter. Side is also 8 centimeter and its radius is also 8 centimeter. So area of design is equal to, so first area of the first quadrant I am choosing A, B, E, D. Quadrant A, B, E, D. This quadrant I am going to subtract the triangle, so I will get this region. The triangle, and it is a half into base into h, we can use triangle. Which triangle is A, B, D? So this we will get upper region, plus the same I am going to apply for the this region. So area of quadrant, here what quadrant is CDFB. CDFB minus area of the respective triangle. What triangle it is? CDB. So this triangle is neglected, we will get this region, right? So from this quadrant, this triangle is neglected, we will get this region, and from this triangle we are going to neglect. So from the quadrant we are going to neglect this triangle, so we will get this region. So that's both we are going to add. So area of the quadrant is a half into, sorry, 1/4. 1/4 into 22 by 7 into the radius and side, everything is 8, right? So 8 into 8 minus the area is a triangle is half into base into height. Here is also 8. So plus here 1/4 into same 22 by 7 into 8 into 8 minus half into 8 into 8, same. So both 2 times, right? So it's later to put a 2 times, 2 into 1/4 into 22 by 7 into 8 into 8 minus half into 8 into 8. Clear? Same. So now we are going to simplify it. For 2 times and 11 times, anything more to simplify? No. So 2 is common, we can take 2 denominator is a common, and inside we have 11 into 8 into 8, 8 into 8 is 64, so 11 into 64 is 704, divided by 7 is that, minus 2 we have outside, and 8 into 8 is 64, so 2 get cancelled. So here we can take an LCM. 704 minus 64 into 7 is 448 divided by 7, so difference is 256 by 7. Decimal will be going longer, so let me stop in the fractions, and this is the area of the design that we needed. So only thing you have to view, just view this quadrant. I'm just redrawing again this quadrant. From this quadrant you just remove this triangle, you will get this upper region alone, right? Now view this quadrant, right? This quadrant, don't do this. Then with this quadrant you just remove this triangle, you will get this lower region. So just we are adding this 2 regions. Thank you.